Okay, so let me start from some of the maybe some of you don't really familiar with Supermicro. I will give you some of uh, information regarding Supermicro. Actually, we are founded in Silicon Valley in 19th century, and up to today, we have reached out to 4 billion revenues in total, and we have the global presence. We have operation centers in Silicon Valley and also in Europe, and Taiwan is the APEC headquarters. So we are ranking almost in a Fortune 1000 company, and we have more than 2 square feet global manufacturers, but the overall is 50% in United States. Most of our engineering capacity is located in headquarters in Silicon Valley as well as in Taiwan. And we are very focused on the server and storage nodes in data center. But for the new business markets focused on the cloud, AI, and the edge compute and 5G private networks, we have the total solutions from the cloud to edge. Just speaking to the previous information, we have presence in Netherlands, in Europe, as well as the Silicon Valley. But today, which is based in Taiwan, to better service our customer and partners in APEC region. And we are now ranked in number 54 in NASA by revenue. So this is the growth path for Supermicro. When the company established, we are much focused on the channel business for the distribution, and we focus on the motherboard and chip building block only. But in the second journeys, we are now focused on the vertical for CSP and OEMs, and we're starting to define our server systems, such as Big Twins, NVMe storages, and Ultra Super Flat, and GPU servers, etc. And today, while we are moving to a new business transformation, focused on digital transformation, Supermicro is now doing the software innovation as well. We are providing the management software for our customer to better remote monitoring their servers. And with building block architectures, we can save our engineering resource and bring the products to the market in the first time. So with the building block product design architectures, we have the chassis design and the cooling. Besides air cooling, we also have the liquid cooling. So we can save a lot of engineering resource, and we can scale up quickly for time to market. So as you can see that Supermicro provides 12-year longevity subsystems, and it's a modularized design for lower hardware compared to competing brands. Supermicro has the much cost-effective product solutions from the edge to cloud. So speaking to the new markets, Supermicro is very focused on the IoT sectors, especially focused on the AI, 5G, and automation. So this is the market trend that we foresee we will have the revenue growth from here. So we design the bunch of product roadmap to fulfill those foreseeing revenues. So in the 5G sectors, now we are aggressively joining those the associations for O-RAN and also the edge compute. As you can see that we are partnering with those silicon providers. We have very strong relationship with those major silicon providers to bring the users best experience of using Supermicro products. So this is the total product solutions from the edge to cloud. From the bottom layer, that mostly is the edge compute that focus we design for fairness box, 1U, 2U, or systems for the edge compute and AI machine learning applications. And we have the GPU server. It's much more for a data center, a multi-node super storage, and those 1U 20 base systems for storage, and also the black solutions that can fulfill the customer's demand all the way from the cloud to the edge. So to enable IoT, today 5G is very important sectors. So the main point is that how we are going to bridge the data from OT to IT, and because from the sensor, from the device, how do we collect those data from the device through the gateway and all the way up to the cloud. So later on, I will share some of the use case that we have done together with our partners, focusing the smart manufacturing, or what we so-called Industry 4.0. So from this page, we can see these 4 countries is actually the world highest industrial output countries. But we normally heard about Industry 4.0, which is launched from Germany in 2013. But the main goal is that because we are now, the global is facing the edge labor, and we are running short of the skilled laborers. To enhance the manufacturing technologies, those major countries launched the economic campaigns to boost up the manufacturing capacity and new technology to fulfill the industrial output. The main reason of doing this is to increase the manufacturing productivity. So as you can see, in 2011, America launched a campaign called Advanced Manufacturing Partnership. In 2012, China launched Made in China 2025. And 2013, Germany launched Industry 4.0. And in 2015, Japan launched Intelligent Robot. So as you can see, for those main categories, the major technologies that to make the productions smarter, to reduce the labor, and most importantly is to fulfill a low volume, high mix manufacturing outputs. So this is the market survey for the Industry 4.0 market forecast. As you can see from this chart here, the the green table, the green parts representing the APAC's growth. So the APAC is the major share of industry markets during the forecast period. In 2024, the total revenue will reach up to 156.6 billion. So in this 156.6 billion, those vertical markets in 3D printing, industrial robots, blockchains, IoT, and AR, VR, artificial intelligence, and 5G digital twins are the main vertical domains that bring up the revenue growth. So in my personal point of view, the industrial IoT sector is the largest contributors in industry for our market, because as we mentioned in the previous page, sensor device all the way up to the cloud. So IoT connectivity is the most important things that we have to have in the industry 4.0 sector. So this is the major infrastructure we have to build up before we have the industrial 4.0 solution in our manufacture. So this is the evolutions of the IT to OT convergence. So in 17th centuries, that mainly those IT and OT is not overlap. But while the time moved to 18th to 19th centuries, we have the ERP in the IT systems, and the industrial automation start launched to the PLC, logic control, and robots. That the more and more PC-based automation gets involved, and in 2000 centuries, that the ERP and the internet and MES, those IT infrastructure getting mature, and those PC-based automations moving to the TCP/IP connectivity, and field bus protocols are moving to TCP/IP as well. So more and more IP is, the PC-based automation is involved in the OT side, and the IT is starting to integrate with those the OT protocols. So this is the area that we are focusing on for the future industry 4.0 growth market, and how we are going to integrate those ERP, MES, SCADA, PLC, and IO data into one unique PC-based hardware. So this is the topic that I will dive in the following slides. Here is the total solution topology for smart manufacturing using Supermicro products. As you can see that we have defined in 4 different layers. That's starting from the level 1. Level 1 is what we call automation equipment. That's the eco partners that we hope that we can engage with. So with those automation equipment that sometimes might be involving with the smart sensors, PLC integrations, or the production equipment we have to align with, and with those wireless smart sensors, CNC robot, injection machines, and power generator. Those are the manufacturing equipment that we normally see at the shop floor. So behind those equipment or the devices, you will see that the data has to link with the PC-based system, no matter it's embedded motherboard or the system layers. So Supermicro provides variety of the solutions, all the way from the embedded motherboard from 3.5-inch micro ATX, mini ATX, ATX, and the pole mount IP65, while temperature range systems FNS controller, 1U rack mount, a compact wall mount system, and 4U rack mount system that can fulfill the PC-based automation applications. And from there, we have those data kept in those PC-based systems, and that is easily for us to convert those data to cloud. So now what we have to do is that we have to connect with those what we call level 2, the communication technologies with industrial IoT gateways. And again, that Supermicro provides variety of FNS bus PC with those field bus or the PC-based protocols that we can hook up with those manufacturing equipment data and send that to the cloud system, whether it's a public cloud or private cloud, through the 5G private network. And when the data goes up to the cloud, we can utilize those data to define the visual dashboard for remote monitoring applications, so that enterprise can easily understand what is going on, what is the production outputs every day from my manufacturing through this kind of architecture. So even now we are in the COVID-19 pandemic, some of the factories that wouldn't allow people to go in as we have in previous days. But with this kind of architectures, the management would be very easily to understand what is going on at the manufacturing daily. So again, here is the architectures of 5G private network smart manufacturing. So as you can see from the bottom there, that representing the OT side. So each block is representing each vertical applications, and the top layer is that representing the IT infrastructures. So in here we have the FNS gateways that can connect with those safety systems and bridge those data to the cloud. And again, the factory automation or process automation system can utilize the FNS bus gateway as the IoT gateway to collect those data from those sensors. And this is the predictive maintenance using the FNS bus PC to collect those vibration data that generate from those diesel engines, and those data is collecting from the PLC/I/O and all the way to the through the Ethernet switch and connect to the IoT gateway. And this is the advanced meter infrastructures with those wireless sensors such as ZigBee, Wi-Fi, or those connectivities. And it can also utilize the IoT gateway to get those data and digitalize those data, send that through whether it's a private 5G network or the industry internet, all the way to the data center for to keep in locally, or even we can share that to the public cloud. So this is what we call a hybrid cloud application. The enterprise can choose whether they can keep their data in their private cloud, which is their own data center, or share those not very critical information to the public cloud for remote monitoring application or the remote access. So here is the some of the detailed background of Supermicro industrial IoT gateways. So in this gateway, we have software protocols that can enable OPC UA, ProfitNet, Ethernet IP, or the EtherCAT and Modbus TCP. So as you can see that those software is defined with those cloud connectivities. So we will be able to hook up those data, those field bus data easily with those major cloud company. And the software is defined with the UI or HMI dashboard. So in another word, you can design your local HMI dashboard with this software, with this IoT gateway architectures. And we can remote config those data. So in other words, that the engineer wouldn't have to go to the manufacturing site. They can simply log in to this gateway with IP address, and he can configure all those field bus and the cloud data remotely with their laptop in the office. So this is the software architectures of the IoT gateway. So we have those major field bus protocol enabled. But besides those protocol that I mentioned, for example, if you would like to enable a Bluetooth or the CAN open, we have to have add-on. We have to have the add-on module in the in our gateway to have the physical connectivities. And then in this software, we can bridge all the data from the sensor to the cloud. So here's some of the scenario of the Modbus RTU master. As you can see, those applications are mainly used for machine or equipment that need to be monitored by Ethernet or to MI system or the cloud. So take the example here for the equipment that is monitoring the water tank level and the flows. So here is the solution that the manufacturer maybe have in their legacy equipment. For example, they have the HMI or PLC or power meter at the manufacturing floor right now. But the problem is that those are the legacy systems. They don't have the capability to link those data to the cloud. So what it does is that we don't have to change all those equipments to the latest version. What we have to do is that we simply add on the gateway using the Modbus TCP to hook up those data in this gateway, and we can remote config those data and send those data to through the MQTT or HTTP to the IT infrastructure. So by doing so, we can simply turn that data from OT to IT for remote monitoring applications, so that the supervisor doesn't have to stay at the local site to understand what is going on. And they can even set up the trigger alarm. For example, when the water tank is lower at certain range or above certain range, the alarm will be triggered, and the gateway will automatically send the warning alarms by email or by the SMS to the supervisor, and they can take the immediate action to resolve those problems. So here is another user scenario for Modbus TCP. So people might know that with legacy SCADA software, they don't have a capability to hook up those data to Ethernet. Again, simply add on the IoT gateways. We can connect those devices with Modbus TCP and configure those data and send the data to cloud for remote monitoring application. and we can simply turn that SCADA systems from the edge to the cloud. And here is the third scenario for field bus connectivity. So as you can see from this scenario here, we have the PLC is doing the master, collecting those data from the sensors. But what we do is that we can add on those IoT gateway for data acquisition. Once those data is collecting to the gateways, we can configure those data and sending those data either to the MES or to the cloud. So this is the scenario that we can doing the digital transformation, sending those PLC data from edge to cloud. This is another scenario for AI inspection that we have done in early for Taiwan manufacturing earlier this year. So what we do is that we have integrated the Finished Box PC as the Edge AI inference. Also, it is playing another role with the IoT gateways. So as you can see from here, that this Finished Box PC is actually linking with the SCARA robots with Modbus, collecting those robot operation behavior data to the gateway. And also we have the IP-CAM is taking those manufacturing process images to the Edge AI to this Edge AI for the AI inference. And with the web-based dashboard, user can simply remote logging to understand what is the daily operation of this production line. And those data is seamlessly hooked with the shop floor system. So that management would be easily to understand the daily output and the operation status of this production line. So in the following page, we will have the deeper insight of these solution architectures. So as you can see from here that we have three systems involved in this application. One is the AI inference system. Secondly is the machine learning server. And lastly is the because while we have the model trained, we will have a lot of data that needs a storage server to cap those data. So this scenario is actually doing the machine learning and AI inference at the edge, but there's another machine learning application that we can done in the cloud side. But considering this is a semicon company, so they have their own manufacturing recipe. They don't want to put those manufacturing recipes in the public cloud. So they prefer to do those machine learning and AI inference at the edge. So what it does is that when the operator put the semi products in this conveyor, and when the semi products move to the B point, that it has the RFID to scan those semi products. So the production record will be kept in the shop floor system. And while the products move to the C point, which is the operation or the operator standing, that the operator will start to do the assembly to make the products as the finished products. And while the operation is doing that, the IP-CAM is detecting those finished products and sending those sending those image to the edge AI inference to do the inference matchmakings to ensure those product is well assembled. And then finally, the finished product will move on to the next station for pickup. So in here, we have the machine learning servers to doing those model training. And those trained model and the historical data and images will be kept in the storage server. And once all those training model is done, that the model will be deployed to the edge inference for the AI inference applications. So this is the total infrastructures from all the OT to the IT. So again, as we just mentioned, those this Phoenix Box PC is also playing the another role as the IoT gateway, collecting those operations data and sending those data to cloud. And once those data is uploaded to the cloud, that the enterprise can easily utilize those data and define those data for the microservice application. For example, they can define those data, utilize this data to define the dashboard for facility management. For example, they can understand the carbon dioxide and or the PM 2.5, those particle monitoring in the manufacturing facilities. And also they can decide the production management dashboard to understand the daily operation for and the usage of these equipment. And again, they can utilize those data for energy management and predictive maintenance, operation management, and device management. And with these microservice systems, we have reserved the PCI expansions for whether it's a GPU, add-on cards, or the 10G Ethernet connectivity card for users applications. So here is the automations that we see in 2020. We are still utilizing those POC and those automation controls separately, and integrate with the IoT gateway for cloud connectivity. But in the future, that Supermicro foresee that we can use the hypervisors to integrate those applications in one unified PC-based hardware for those automation controls. So this is the vision that Supermicro foresee in the past few years, and this is the growth momentum from Supermicro's vision. So here is another user scenario for automotive manufacturer located in the United States. So we have separated that into three phases. First phase is the body shop. The second phase is the painting shop, and the third phase is the assembly and final assembly. So let's take a look at the phase one. So here is how Supermicro products fit into these automotive companies. So in this production line, they have those 12 robots doing their welder applications, and we are using Supermicro products to collect those data from the IP cam and the automatic and the robot operation behavior, and sending those cloud to the data centers for the whether it's the AI inspection or the the operation analysis for those robot behaviors. So with this welding automotive company, they have 83 global sites, and each site they were starting enable this kind of solution architectures to make their product flow more efficiently. So this is the this is the sorry, yeah, oh, okay. Now this is the reusable comment. This is a very the solution is a modularized design with our software partners from NetApp and the NoWeaver. So what it means is repeatable. If those once they have proved this proof of concept, they can easily deploy those solutions into other 80 sites globally. So here is the first phase is doing the body shop and also the painting. Again, that those data is collecting from the manufacturer site and send it those data for the data analysis to the enterprise cloud or the up to the public cloud. And here is the assembly site doing the same scenario as well. So moving towards from the industry 3.0 to industry 4.0, I think the major point is that is the computer integrate into manufacturing, because every manufacturing is choosing systems and automation lines, factory MIS, facility management systems, they all need a PC base to perform those applications. And once we have those computer integrate into manufacturing, then we can move on to the SCADA and the process control. And behind that, they also need a computer to run those software applications. And thirdly, with green energies, we have to highly rely on those IoT gateway to collect those energy data from those sensors and power meters, and then transform those data to the IT side. And then we can design, as we mentioned, a cloud-based dashboard for remote monitoring. And it can save a lot of operation costs for the enterprise. And once we have all those data into the IT side, we can utilize those big data for example, the product quality management and the predictive maintenance. And lastly, of course, is our final goal, the Industrial 4.0 implementation into our manufacturing side. So here is my last takeaways. If you are engaging with some of the opportunity with the manufacturers, perhaps they need a SCADA system or the edge compute. So for that's starting from the bottom layer, which is the edge compute. We have the furnace spot systems and the compact one-use systems and desktop and wall mount systems and the IP systems for the edge compute, machine learning, or 5G connectivities. And in the middle layer, which is the mid-level control SCADA station with 1,000 tag, we have those systems that can fulfill the user's demand. And for the high-performance SCADA system with 3,000 tags, we have a core I systems that can fulfill those applications. And for the central SCADA station with more than 5,000 tags, we have Xeon processors that can fit into this application. And lastly, with our variety furnace bus gateway, we can simply utilize that as the IoT gateway to bridge those manufacturing data to the cloud. So thank you. This is my presentation with some of the visions with Supermicro in Industry 4.0. My name is Kai Wang, Senior Business Development at Supermicro. So if you have any questions, please don't be hesitant to contact me at the email from the PowerPoint slide. Or you can simply contact your local contacts for Supermicro products. Thank you.